Hey guys, so welcome back. I guess this is how I'm going to be teaching you calculus now. I picked Jean Adams stuff, the flamingo math, just because she follows the units, and I feel like that's our best bet for trying to do this virtually and hold on to some sort of something that we've done before. We are going to go through topic 8. I don't know how the assessment's going to go at the end. We'll kind of cross that bridge when we get there. For now, we'll be doing lessons and homework. So I'll go through her lessons. I'll pick what I want to pick out of it, and then I'll have you do the homework on that. Eventually, we will have a quiz. I understand that the quiz will be group. You guys can do it however you want to do it. If you want to set a time, we can do that. We can figure it out. We can chat about that later. But for now, I want to get through 8.1. I'll do the notes today. I'll go through the notes, and then you have actually all the notes. You have the entire notes. I bought the whole deal. I bought the whole Unit 8 from her. So you have the whole thing at once. So if you want to open it and print it, you can. If you just want to write on your own paper, you can. Just write the important stuff. However you want to handle your notes, you can at this point, which you've always been able to do anyway. And then as far as the homework goes, the same deal. You can print it, and then you'll be able to send it to me or not. Just do it on a separate sheet of paper, and then give me that piece of paper. You could not print anything. So you're going to have to kind of handle that however you see fit. So here we go. Let's do some calculus. I know it's been a while, and you've probably been very, very sad. So, she does mention the mean value theorem for integrals in this, which that is not something that I think that you need to focus on at all. So it is a good thing to know that it exists and kind of understand how it works. But the thing I want you to know the most is the average value function, which is more talked about down here. So, oops, my bad. So what the mean value theorem is saying is on a continuous closed interval from A to B, there exists a number C on the interval such that, okay, let's look at this closely. So the integral from A to B of f of x dx, that's the area between the curve and the x-axis. So that would be like, it's hard to even say, like the green and then plus the yellow. So that equals f of c times b minus a. This line here is the average. This is actually the c that they talk about. So the height here times the length, which is b minus a. So this is really just the area of a formula. My bad. Area of a rectangle. This is the height. This is the base. Okay, so that's mean value theorem for integrals. Now what I really want you to know is the average, be able to find the average value of the function and just understand what you're finding. So the value f of c is given in the mean value theorem for integrals. It's the average value of f. Average value of f is the average height, or how high it's going on an interval from A to B. So if f is integrable on the closed interval from A to B, then the average mean value of f on the interval is, and here's a formula. And if we got to do formula quizzes again, that would be on it for sure. I do want to try to make you guys do those note cards again, or not again, but I would like for you to do them before the AP test happens. So that would be one of those. All right, so that is the formula that we're going to be using today. So let's do it. Example 1, you're given the function f of x equals 3x squared minus 2x. Don't worry, I brought my pens home to teach you. Yay. Alright, so let's set this up. It says find the average value f on the interval from 1 to 4. So that's our b and our a. So 1 over 4 minus 1, and then our integral is going from 1 to 4. of 3x squared minus 2x. And of course, we need to have a dx in there. So now you gotta remember how to do an integral. So this is 1 over 3. Oh, nuts. I didn't mean to put that. And we'll write it again. 3x squared minus 2x dx. Okay, so evaluating the integral, we have 1 over 3. This would be 3x to the third over 3 minus 2x squared over 2. And we're integrating from 1 to 4. So to neaten this up, make it a little prettier, we have 1/3 times x cubed minus x squared from 1 to 4. Alright, so plugging in our numbers, you have 1/3. That would be 4 to the third minus 4 squared, and then minus plugging 1 in. 1 to the third minus 1 squared, which will actually cancel each other out. So 1/3 of 64 minus 16. This would actually be minus 1 plus 1. Like I said, they'll cancel out. 64 minus 16 is 48. So 48 divided by 3 is 16. So the average value of that function, oops, my bad, sorry. The average value of f on the interval from 1 to 4 is 16. All right, and then B says to find the value of C guaranteed by the mean value theorem. Nope, not doing it. Okay. So example 2, I do like this one. Excuse me. In 2000, the world's population was 6.1 billion and the relative rate of growth was 1.4% per year. This can be modeled by the function blah, 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 where n is people in billions and t is the number of years since 2000. Assuming this model remains true until 2050, find the average population of the world between the years 2010 and 2020, and what are the units? All right, so 2010, 2020, this all starts in 2000. So that means we're going from 10 to 20. All right, so that's our interval is going to go from 10 to 20. So we're doing the average value. So 1 over 20 minus 10 of the integral from 10 to 20 of 6.1 e to the 0.014 t dt, or 1 over 10 of that integral. Now this integral we're going to have to do on your graphing calculator. I don't know what your status is on graphing calculators. I know I really wish I had brought my charger home because my battery is dying. I didn't even think to grab that. Oh, but I don't want to clear this. Okay, so this is actually a graphing calculator one. So we'll go to our y equals, I'm going to put in 6.1 e to the 0.014 t or x. Graph it out. That is not big enough because we need to go from 10 to 20. So I'm actually going to change the window. Nope, I don't need second. Just window. Alright, so from 10 to 20, see this graph? It's not a very exciting graph. But I need to find the integral for that area. So I'm going to go second calc, number 7, lower is 10, upper is 20. Wait for it. So we have 1 over 10. If you look down at the bottom there, we have 75 0.315834. So it says find the average population. To give my final answer, I'm going to round to 3 decimals. So that dividing by 10 moves it back 1. 7.53, and then it would be 2. And then this is billion people. So this is the average population of the world between these years. And don't forget to put a billion people, that's pretty important. It's way different from just 7.5 people. And then I do like this problem on example 3. It says, suppose CFT represents the daily cost for air conditioning for your house in dollars per day, where T is the time in days and T equals 0 corresponds to July 1st, 2017. Explain what the following expressions represent in real world terms, including units. All right, if we go from 0 to 90 of CFT, this is the total cost to cool your home. For 90 days. So for July 17th, 2017 to September of 2017. And then this, this is the total cost. This is the average value. So the average cost. Cool home. Your home. Let's just say for 90 days. All right, so I did 2 examples where we had to actually evaluate average value. Hopefully that's enough to get you through the homework. Look for the assignment in Teams. Tomorrow you will do it. We can discuss it. We're going to go over the answers, blah, blah, blah. And then Wednesday we'll do something new. So I hope you are bored enough to work on your calculus now. And I hope you're all staying safe. And I will talk to you all soon. Have a great day.